In this video, we're going to go over key features of quadratic functions again. We're just going to be adding on when it is positive and negative. So as a review, x-intercepts are when it crosses the x-axis, and it would be labeled x, 0. Y-intercept is when it crosses the y-axis at 0, y. Minimum or maximum just means that your vertex is the highest point for maximum or the lowest as a minimum. Axis of symmetry is the middle and is represented by x equals whatever number it is intersecting through. Where the function is increasing or decreasing. Increasing is where the graph goes up. Decreasing is where the graph is going down. Where the function is positive and negative, which is going to be the new part today. And the end behavior of a function will be honors, but I'm going to teach it in case you want to try. So the function is positive on the interval where the y values are positive. The graph of the function is above the x-axis. So whatever's above the x-axis is positive. Then negative is going to be below the x-axis. These ones are going to look a little weird, but once you get used to them, you might like them a little bit. So for the positive section, on the left side I have negative infinity, and it's still positive until it hits right here. At that number, -2, it is no longer positive anymore. So I'm going to write negative infinity to -2. Then there's a gap, so I'm going to use a union. This is negative down here. Then from here, number 2, it is now positive again, and then that arrow means it goes on for infinity, positive infinity on the right. That would be my positive section. Anything below the x-axis is a negative. So it would be negative from -2 to +2. And that's it. Let's try another one. Here's my graph. Oh, it's the same one. We'll do it again. Negative infinity on the left. It stops at -2. There's a gap. Then it starts up again at 2 to infinity. It is negative from -2 until it hits at +2. Notice there's 2 pieces above, so there's 2 intervals. There's only one piece that's negative, so there's only one interval. They should match up. Sketch a quadratic function that is always positive. That would always be positive because nothing would go below the x-axis. This one would be always negative. So if it asks you for positive and negative, you would say no positive, all is negative. Same thing here, this would all be positive. Oh, I'm going to correct that. I'm going to put none. There we go. For the honor section on end behavior, if you are wanting to do that, we are going to look at end behavior of the graph as x becomes positive infinity or negative infinity. It's kind of weird. I'm going to show you what that means. So there are only two ways we can write our end behavior for quadratics. So these are the only two ways. So they would give you this diagram. And you'd have to fill it in. So if I had a parabola that opens, let's say it opens this way, it opens up. As you go to positive infinity, so as you go to the right, your graph is going up. So you would say positive infinity to say it's going up. Then you evaluate. What happens if you go to the left? What if you go to negative infinity for x? Then your graph is going up again. So you would put positive infinity. You don't have to write the words. The words would not be in there. You would just have the infinity signs, and that would be your end behavior. The only other way a quadratic can open would be down. So let's try it. As you go to the right, where is your graph going? Well, this graph is going down as I go to the right, so I'm going to put negative infinity. What happens if I go to the left? That side is also going down. And that's what the end behavior is. So if you want to try and do these, they will be extra credit on the test because they're the honors section. Example 4, vertex, 0 up 4. Axis of symmetry is the line that cuts down the middle, and it cuts down and hits at x is 0. Intercepts, -2, 0, +2, 0. You guys are going to be pro at this. Y-intercept is 0 up 4. It is a maximum because it's the highest point. The domain has arrows, negative infinity to infinity. I'm going to be mean and make you do the range. That's the highest y. So my range would be negative infinity until it stops at +4. Using the same graph, it's just a copy so that we can color it again. When is the function positive? From -2 to +2. That's when it's positive. When is it negative? Well, I have negative infinity on the left until -2. Then there's a gap. Then from 2 to positive infinity on the right. Because I have to have the two intervals for the negative section on this one. If you do the end behavior for extra credit, as you go to the right, your graph is going down. As you go to the left, your graph is also going down. And that's the end behavior. Vertex, +1 down 4. Axis of symmetry crosses through the number 1, x equals 1. X-intercepts, -1, 0, +3, 0. Notice I always write them as a point. Y-intercept is at 0 down 3. it is a minimum because it's at the bottom. The domain, the arrows mean negative infinity to infinity. It would continue. And the range would start at 4 and continue going up to positive infinity. So negative 4, and it continues to positive infinity for the range. For today's section, where is it positive? Negative infinity until it hits at, that number is, that's kind of hard to see. Is that 0 or negative 1? That's negative 1. Negative infinity to negative 1. And there's a gap. 2, 3. There are 3 to positive infinity. My negative section would be from negative 1 to positive 3. If you do the honors section, go for extra credit. As you go to the right, your graph is going up. As you go to the left, your graph is going up. Done. If you have any questions, please come see me.